Take it away. Thank you, Pierre.
Thank you, Rosa. Okay, so thanks for the kind introduction. Morning, everyone. Indeed, we just flew in. We got stuck for the night, but managed to make it on time, which is very exciting. This is the first BrainHack here. So yeah, first BrainHack ever here. I get to witness it. Very exciting. So Rosa and Katie asked me to talk a little bit more about open science. So it's not going to be a kind of talk I usually give. It's more going to be about technologies to do science and communities to do science and the science itself. So as Rosa mentioned, I've been involved in the BrainHack series since it started in 2012. So it's been about 12 years. So we'll just focus on different initiatives. I was involved over more than a decade now. And I'll get back to the first part of that title, to build a home, 12 years of BrainHack. So we're going to start with 12 years of BrainHack, and then maybe hopefully you see why it's kind of a home. So part one, what's Le BrainHack? It is a format that is puzzling for many. And there's a couple of words in there which can be misleading. So some people, when we talk about the BrainHack, they think about there's this scene in the Matrix where the main character sort of gets a chip in his brain and all of a sudden knows Kung Fu. And people think like that, the kind of BrainHack we're doing. We're not doing that. Once on Twitter, somebody kind of started stalking me saying, you need to stop hacking brains of people. I'm not hacking brains. Maybe not yet, at least. The other thing people think about is because there's hack in the title, so they think maybe there's some kind of piracy involved, people breaking computer systems, and that's what they're doing at those events. And once again, absolutely not that. There's typically nothing illegal going on at the BrainHack event, at least we hope. They won't. Please refrain from infringing any law. But there is still a connection with the hacker movement, but not the piracy aspect of it. So that person here on the screen is Richard Stallman. He's a pretty famous computer scientist, originally based at MIT, and he was part of the original hacker movement in the 60s and 70s at MIT. He developed something that's called GNU. It was sort of a project called open source software to do everything, including editing text or running a computer. Eventually, the running of the computer part was taken over by Linus Torvald and Linux. But still, if you have a Linux system on your computer, lots of the code that's running is GNU code. So he's very famous, very inspiring, and he spearheaded, open source software, which he calls free software. Actually, I think he still wants to call it that. But anyway, I put a few quotes from that person that kind of encapsulate another way of thinking about what hacker means. And the first one is being a hacker means appreciating playful cleverness. So a sense of having fun, which definitely is something we can use in science and is sometimes easy to forget. And the other one, that sharing is good, and that with digital technology, sharing is easy. And that is obviously true of code, and that allows to collaborate at a scale that was simply not possible before this type of technology came into being. So I think a lot of the people who have been involved in the BrainHack have been really striving for this type of more communal effort about building infrastructure and tools, amongst other things. Now, I want, for those who are not familiar with Richard Stallman, then that's fine. It's a nice little introduction. For those who are familiar, you may know it's a fairly controversial character. I will not detail about this, but if you want stories about Richard Stallman, I have some. So you can come and find me later. So I don't condone everything he says. It's just an important historical figure. So BrainHack really emerged as a community of researchers who are themselves multidisciplinary. Their research often happens at the intersection of several fields that are typically taught and practiced in silos, including neuroscience, statistical modeling, and computer science. And pretty much, nobody coming to do this type of science is fully prepared. And so it takes some exchange of ideas in order to make good advances. So as I already mentioned several times now, it started in 2012 at the Max Planck Institute in Leipzig, hosted at the time by Daniel Margulies. And I think one of the key values we've shared across the events and a staple is collaboration over competition. So I would say that if I had to give the sort of like too long didn't read short version of how BrainHack operates is like, I will contribute to your project if it's not too difficult. So people come here and kind of like see what's of interest and try to help each other. And that's something that can happen in a conference, but there's generally several annoying things in the way, like talks, conferences, keynotes. So the idea was really to take like what's good in a conference, meeting people and developing ideas and getting rid of everything else. So hopefully, over the next 2 days, you're going to enjoy that process. Over time, thanks to initial leadership by Cameron Craddock and then very energetic team of people, there was lots of local events such as this one that started being organized. So there's this little timeline that was prepared in a paper by Rémi Gaud and colleagues. The author list is very long because almost all of the people involved are being listed, at least in the consortium. But that map is now 3 years old, but it's continuing, and I'm really glad that we now have a little circle in Vanderbilt University, Nashville. This is awesome. I say it's a global community because the name of the event is like BrainHack Global. However, I would note that there is some pretty strong bias in some parts of the world and some others are largely excluded. So, hopefully we can do better in the future and make it even more truly global, but at least when it comes to, North America and Europe, it's pretty good. The other thing that came out of this series of events is really, the idea was not to say, oh, you've got 2 days and you do a project, because really in 2 days you don't do much. The idea was more to say, 2 days you meet, you discuss, and you meet again in a year, and things go over time. And so fairly early, we established an online space for this collaboration to happen throughout the year. So we started with a Slack back in 2016, which was the early Slack days. And then there was a very controversial decision in 2019, we moved to Mattermost. And I think it's controversial because people don't like Mattermost and actually quit space because of it. And I'm really sorry we didn't do that well. But anyway, we did it with the idea that Mattermost is hosted on our own servers. There's no issue with privacy and so on. And currently we have almost 6,000 users there. I mean, they're not all active because anybody who registered at some point at the BrainHack is on there. It's a much smaller community than this. But still, I think it's a testimony to the fact that, a lot of people get involved at some point with the BrainHack community. So that was my kind of like 8 minutes and 59 seconds introduction about what BrainHack is. So it's for part 1, so we know what we're talking about here. So now I can move to part 2. What's in it for me? Because it's a very common question. I've seen many more senior researchers hesitate to send their students at the BrainHack. And I've also seen many students investing a lot of time in BrainHack, but then not being really sure this is wise and that this may damage their career. So there's a question of like what exactly comes out from participating in this kind of events. So back in 2015, we had started this like hackathon as a satellite to a conference called Human Brain Mapping, which I'm guessing many people here have heard from or maybe even went to. And the 2015 edition was in Hawaii and organized by someone called Nolan Nichols. And he had made some little scribbles about like what had happened. And I somehow, I don't even remember how, I got a picture of this. And I love this page because I think it's pretty much spot on. So it's the first section with it's like what was done, collaboration, education, support, expertise in one place without bias, spontaneous collaborations, and work on resources and infrastructure. So, you know, just a lot of overlap in terms of keyword I was telling so far. Now, how it turned out, no deliverable and scope is too large. I this one, because, you know, in 2 days, you won't do it. I mean, you can do a few things, depend, but generally people are overambitious, and really like those projects that they develop over time, there's no competition to win, there's no prize to be won. It's more about like creating a network and starting things for the long haul, basically. Next point, teams formed with, you know, a number of developers from many institutions, rapid learning, 2 months compressed into 2 days, although I'm interpreting an arrow here. Distribution of essential work, underlining essential, and I'm going to try to, you know, develop why I fully agree with this. Research assistants, postdocs, and students, career support, obvious passion. I think that's correct. And then this got the future section, and I highlighted neuroscience is a new type of data science, which, you know, is definitely what materialized over the past decade. And I don't even think I need to make that point. Actually, maybe even the term data science is a little bit obsolete now. It's like so embedded in whatever we're doing that not even really worth mentioning. So to explain a little bit more what that looks like, I've borrowed some slides from a postdoctoral fellow working with me. Her name is Dr. Aoting Wang. And she worked on a project that we started as a BrainHack project. So I'm not going to get into the details of our findings, but more highlighting what the process looked like. So when we started working in the lab at some point, we started really processing large amounts of data fast. And I've noticed that we use this standardized tool to pre-process functional MRI data. It's called fMRI prep. And then we did all our statistical modeling, or at least, you know, the initial data loading phase with a Python toolbox that's called NiLearn. And I'm also pretty sure many of you are familiar with those tools in the room. But when we went from one to the other, there was an important step, which is denoising, that was not really standardized. There was not a good API to do it. fMRI prep essentially generates lots and lots of things you could maybe want to do, but then they leave you on your own to decide, you know, which one to use and how to apply them. And I started noticing, you know, students just messing it up in very creative ways and doing things that were either fully incorrect or just not what they were thinking they were doing. So we had a problem how to go from fMRI prep to NiLearn in a way that was standardized. Now, there was standardization in the literature. There was a bunch of papers with things like these tables that's taken from Sirik and colleagues in 2017 that highlight different types of strategies that one may want to do in terms of denoising. And they provided some, you know, guidelines about how well those type of strategies would work. But as I mentioned, getting from that kind of table representation to an actual snippet of code that does work is not a trivial task. And the fact that there was no standardized tool to do it meant that, in effect, people may end up doing different things while having the same goal. So at BrainHack Montreal, back in 2021, I started a project on this. There's a bunch of people who joined. We decided to write a small piece of Python code. And Aoting was part of that group. She really liked it. She didn't have a great time at her current institution, so she just left her institution, moved to Canada, joined my lab, worked on this full time. And instead of just finishing that project and make it a toolbox and tell people, okay, we got this new toolbox, load confounds, please use it, she really went the extra mile and took about 6 months to push that as a new feature in the NiLearn library directly, which was a fairly painful process, even though the library worked fairly well, but integrating in that other code base and going through all their requirements actually took a while. So right now you can do this with a recent version of NiLearn. From NiLearn interfaces fMRI prep, you can import load confound strategy. And then you've got your file names from fMRI prep, and you say load the confounds with a simple strategy, and you get the confounds and you're ready to go. and it's been tested, and hopefully, it will be the same thing if somebody else using the simple strategy. So I got this little schematic to summarize what we've done. We had a problem. We're missing an API between fMRI Prep and NiLearn. And what we didn't do is create a new tool. Instead, we just made better tools. And also our team now is part of the core development team of NiLearn. She's maintaining software. So if you yourself add a feature there, there's a chance that at some point she's gonna help you and fix bugs if bugs are being reported, even though you're not necessarily involved anymore. So I very much believe that this type of communal work is what we need to have high quality scientific tools. And that when labs develop tools on their own, it's very hard to maintain over time, especially when the initial spark of excitement is gone and all is left is a very boring tool that you know how it works, but you still have to maintain it because thousands of people are using it. This is very brutal to be in that position, and I don't wish that to anybody. So if you have a distributed community that can share that load of maintenance, it makes a huge difference in the long term. So just in passing, our teams then moved on and tried to rerun the type of benchmark studies I was mentioning, evaluating the quality of predictive noising strategy with these new tools. And because they are so easy to use or to code, she was able to automate, essentially replicating all papers, but with recent software implementation, and making the entire evaluation of denoising fully reproducible. So maybe in the future, when we have new versions of fMRI Prep and NiLearn, we can actually rerun all the evaluation of the strategies in a pretty straightforward way. So instead of having a snapshot of evaluation of denoising that only applies at the date where the paper is out, it's more of a living evaluation, which I think is something critical when we rely on tools that release new versions every year. So you can check out the preprint, which hopefully will be accepted for publication very soon now, and look at our recommendations. But that little slide is for me a perfect transition to my next part, the academic currency, papers. So papers are the very frustrating. Why? Because they're often accompanied by code, and that code is in a very weird state. The code typically can be retrieved. So it exists, so it's not dead. But running it is sometimes very difficult because you will require some dependencies which may or may not be easy to install today and which will likely die and break in about 2 years. Maybe there's a container in there that ships some dependencies, but mileage may vary, quality may vary. So that's the zombie code. But the zombie code in itself is just part of the problem because that zombie code typically operates on mummified data. So what is mummified data? It's data that is accessible, at least if you ask for it, but there's a lot to unwrap. Okay, so the joke is not from me. It's Aga Karakuzu, who is a postdoctoral fellow working with primarily Nicolas Tikoff, but I'm also involved. And he prepared some slides. I have nothing to do for that. I forgot to say this. All the slides of that part are from Aga. So yeah, I mean, the data may not be fully documented, or the point of contact between the data and the code may not be all that clear, broken path, things like that. So for something like 6 years, we've been working on a new platform that is not the only one of its kind, but I think it's a pretty unique combination. It's called NeuroLibre, and its aim is to kind of like resurrect your publication to turn them into more living papers than those mummified, undead things. So there is a website. It's called neurolibre.org, and I'm going to actually look at it with you right now. There you go. So it is we ended up going for a preprint service. So it's a little bit like bioRxiv, OpsArchive. You can submit your papers through an interface. You log in on the website and you can submit a GitHub repo. It's actually, if you have heard or used the Journal of Open Source Software. This is the same general workflow we've forked. So it's using GitHub for all of the peer review and evaluation of the submission. And we can have a look here at some already published accepted preprints. And I'm actually going to go and check out the one by outing. So when you submit your work, you're going to have your GitHub repo, and you're going to have a number of config files that describe the environment you use to run the analysis and the data you use to run the analysis. And actually, you won't submit the preprint itself. NeuroLibre will compile your preprint for you. So it will grab the data, it will run the code, it will generate the figures for you, and it will generate the final document. So what you see in the paper is reproducible because it's being reproduced as part of actually getting the preprint in. And when we decide to finally accept a preprint, we archive cleanly all those artifacts. So here you have a little PDF, but we just generate that, so there's proper metadata, so a digital object identifier, and all the citations are properly handled. But on the right, you'll see that there's an archive for the data, an archive for the container with all the dependencies. There's an archive for the original code, and so on. There's also a little button that's pink with sparkles. So we're going to click on it, obviously. Hello? Can I click? Sorry, I never touch my computers. I don't really know how they work. So this is kind of an HTML version of the paper. And let's go look at the coolest result right away. So there's some figures here. So as I mentioned, those figures have been generated as part of the submission. So they have been tested. That's what you get with that code and those data. I should have noted, where is the figure I'm looking for? That's not it. I'm so sorry. I kind of forgot how this paper is organized. It's terrible. All right, so this figure I really like. It's a little bubble graph. Each graph is for a different data set of evaluation. Each line is a criteria for evaluating the denoising strategy, and each column is a different strategy. We have a bunch of them. And when the cycle is big, that means the method performs really well compared to the other ones. And we see an obvious trade-off where on the first line, you see the loss of degrees of freedom. So some methods aggressively remove a lot of data. And on the other line, you see how well the denoising works. And you can see that the methods that don't remove a lot of data also typically suck at denoising, and the one that denoise really well typically remove a lot of data. So, that you see this little trade-off in the bubble graph. But I don't really trust this, so I want to reproduce it. So you probably know about Binder Hub, but that Binder Hub is really coupled with a preprint service. And the difference with Binder Hub is that it should be fairly reliable. So I'm actually attempting a live demo. That's it. In general, it starts within 5 seconds. So I propose that we reproduce all these results, because why not? Also, this brings me so much joy. Sometimes I have my coffee in the morning, I spin a little Jupyter Hub server, and I reproduce the results of outing. Such a great way to start the day. So the first thing that happens is that it gets the data, but it says data is already downloaded, because obviously it is. We cached it, it's part of it, it's archived, it's on our server, and it won't go anywhere. So we have a couple of gigabytes of data in there, but it didn't take a long time. We are on environment, and we're ready to go. And it's already finished. So truth be told, those are just simple statistical visualizations, so it goes very fast. But yep, Peru, we're almost there. We're almost there. I like this one. It's pretty too. And the bubble graph. Here we go. We have reproduced outings results. All the data is in there. The environment is there. We can change the code. We can mess with it and do whatever we want. It will work. That's a live environment. So here you go. That's a living paper. back to the presentation. So we covered all of that. So what I wanted to say is that this entire technology really is based on existing well-maintained open source tools. And they're also well documented and they don't require a lot of software engineering skills. So there was this journal called Distill.pub, which you may or may not have heard from, but which is absolutely awesome. The articles are gorgeous, but you need to know how to do some JavaScript in order to build this type of submissions. Here, it's like pretty basic Python. It's using something that's called the MIST language, which is a mixture of Markdown and Python. Actually, you can do R or even MATLAB with this. So here you go. And as long as you know how to do a normal Jupyter notebook, you're not too far from being able to submit something to that preprint service. So hopefully you'll try it out. I'm around, don't hesitate if you have questions. So if you want to do it, I'm happy to sit down with you and help you with this. So I'm actually early on my schedule. This is incredible. I should like sleep in random hotels and not sleep enough more often. This is a very strange effect. I'm going fast when I'm tired, apparently. So part 4, the BrainHack School. So obviously I said, if you know how to use Jupyter notebook, you're fine. And maybe some of you are like, what is he talking about? I don't feel comfortable here anymore. I'm sorry. I don't assume everybody knows how to do those things. And actually, even computer science students who join the lab oftentimes lack some of the key skills to do that. Maybe they know GitHub, but they're actually not familiar at all with the process of opening a repository, doing pull requests, and so on. So, as I was mentioning earlier, we have this problem of like multidisciplinarity, which means that nobody comes fully prepared for this. And BrainHack, this event, has an educational track, I believe. We've been doing that since the start. It was always decided to do education, but 2 days is very short. I already mentioned that before. It applies to hacking, but it also applies to education. So definitely you can hear about a number of things over 2 days and then explore them by yourself. But we felt, me and others, that they needed some longer format, kind of the train track, but more like 4 weeks than 2 days. And we've been piloting this for 6 years now. Last year was the first year that it actually was not a pilot, it was a real thing. So what it looked like was we had 8 sites that blocked the same 4 weeks to work together. We had 2 sites in Canada, 2 sites in Europe, 2 sites in South America, and 1 site in Asia, Taiwan. No sites in the United States of America, believe it or not. Shocking. That represented about 100 students, 30 teaching assistants, and yes, that is a pretty crazy ratio, teaching assistant to students, but that's by design, and 17 event organizers. Each of the sites was fairly small, we had like 8, 10, 20 students per site. It was in presential. People went physically to a space at least once a week, but we were also connected through a Discord server, so we could do projects together across sites, answer questions from students across sites, and prepare all the material across sites because we only had 1 website and 1 set of tutorial, so it was very efficient. In terms of the structure, it sounds and feels a little bit like Neuromatch Academy, which is an awesome initiative, but it is actually in practice pretty different. So the first week, you get mostly tutorials, and the idea is that you get exposed to a number of tools. So you can decide, okay, Jupyter notebooks, I didn't know what they are. Now I know, I want to know how to use them. Here you go. So it's more like the menu. You hear about what you may be eating for the next 3 weeks. So you can choose wisely where to invest your time. As of week 2, you define a project, and that project is definitely, it's based on your interest and typically based on your data. So it's not a project-based learning where you're being given already prepared data set and essentially being told what to do. It really comes from each student based on their interest. Several students will decide to work as team, but even if they're not in a group-based project, we pair them based on keywords and interests into little pods so they can help each other, and the pods are across all the sites. So you get to network with folk from other cities. There's still some tutorial, but mostly people are thinking about what they're going to do, and they get feedback about how feasible that is. Week 3, they do the thing. Here's a picture of Anisha and Greg Kia, who are adorable. I miss them. Although Greg is still in Montreal, so I see him every now and then. Anisha, they were the lead organizer of BrainHack HBM in Singapore 2018. They were the one establishing the train track back in the days. And that's it. And week 4, it's just like helping people wrap up their project, wrap up their presentations. They do a little report. So I wanted to show you that to you. And I'm super early on my schedule, so I can totally do it. So that's the website. It's using a framework called Hugo, but all the content is really markdown files, so just text files. So it's pretty easy to collaborate and add content for everybody involved. So the modules, which are listed here, typically we don't create content. We reuse things done by other people. So Neuromatch Academy has a good tutorial, it lands in there. Jean-Baptiste Pauline does something fun at McGill, it lands in there. The BrainHack community generates a new educational content, it lands it there. So at the beginning of the session, we go through each tutorial and we kind of curate it to determine if it needs to be updated. That works through pull request and GitHub, collaborative work. And typically what you have is some videos, some links to code, and some exercises. And then the teaching assistant are going to help check that the exercises are done correctly, and you can ask them questions. Because you can watch a video on your own, you can do the exercise on your own, but if you're not part of the BrainHack school, you won't have somebody to get you unstuck. That's a big added value we try to provide. And then at the end of the school, people open a pull request with their project reports, which are listed here. If you want to have a look, there's like 15 which are not merged yet because I'm the only one merging those pull requests. It's catastrophe. I need help next year, but let's just open one. So that's it. It's got like little tags, so we can add links to repo and so on and so forth. It's got like little visualization. Some of them are quite short, like this one. Others are much more extensive, but at least we get a good feel of what everybody worked on. And also each project becomes a seed for the projects of the year after. So you get this fairly large gallery of projects to give you ideas at the beginning of the school as well. So that's all for the BrainHack school. So we can go back to here. Oh yeah, no, the training module, but I just said that. Just in terms of the content. So some of them are more like, here it says data science 101. We would say like computer science 101, or to use a terminal, or to do scripting, or to debug. And some of them are more like geared toward analysis of neuronal data. So it can be, what is functional MRI, what is diffusion MRI, or do you do a parcellation of the brain, or do you run a deep learning model with brain data, this type of things. So more oriented towards modeling. So that's the list of modules we are currently have. We try to keep it tight. So those are really transferable skills, key type of materials that's really useful to a wide range of students. But obviously, you can always open an issue and propose a PR if you want to add modules, and it will be discussed by everybody to see if we integrate it or not. Which leads me to part 5, alternative spaces. So that's a new part. And that's Cinnamon Adley, by the way. She's a dancer, I believe, from Chicago. She was one of the sort of like, she developed a lot of the gothic fashion and makeup type of things. If you've watched the series Sandman on Netflix, or maybe you read the Sandman comic books, Death in that series inspired by her. She's badass. She looks awesome. So when I explain BrainHack, every time there's like, I'm less used to present this, so I'm trying to correct my thoughts. I feel one of the big events that happened in the growth of that community was back in 2014, and we went in Berlin in a place that's called C-Base. C-Base is one of the first hacker space in the world. It was established by an organization called the Chaos Computer Club, the CCC, which you may not have heard from or may have heard from. But young me when I was 15 talked about them like the Avengers, more or less, like really mythical creatures, but they're actual people, and they have an actual space down in Berlin next to the big tower in Berlin. And we had the chance to actually visit the space downstairs. They have a robotic space, they have a computer room. It's really fun. It's open to the public. If you ever go to Berlin, I would encourage you to check it out. But they pushed all the early things about accountability for banks, finding critical security bugs and making them public, concern about privacy. They're very involved in the politics in Germany actually right now. But like the general operations they have, that they have a simple rule. If you have a question, you want to learn something, you just have to ask. And if somebody asks you about something, you're supposed to actually share your knowledge with that person. It was very clearly aligned with what we were trying to do. And there were these fairly big connections that was obvious. And I mean, I absolutely adore that picture. And that's how actually I was first introduced to C-Base. It's a member of the C-Base community posted online, and he's obsessed. He wears an EEG all the time. He has this crazy setup at C-Base, and on his screen, he had the brainhack.org page open in the top left. So clearly, I mean, that person also had seen this connection between the two communities. But recently, and I read this book, it's here, it's very big, but it's very interesting. I'd encourage you to check it out. It's called Neurotribes. It's a detailed history of autism. So I've been doing research on autism for years, treating it as a label in a spreadsheet. About 10 years ago, my son was diagnosed. So anyway, that book gives a history of the condition, but also draws a lot of parallel with communities like the hacker community, but others like people doing radio and science fiction, and actually going in the origins of this community. There are many prominent figures who have neurodiverse traits, not necessarily autistic, because autism diagnosis is a very recent construct. And some of those communities existed prior to that. And it also struck me that there was a strong parallel with BrainHack, and I've tried to formalize that link. And at least based on my experience, because I share many traits with my son, and it is a fairly cherry-picked, arbitrary selection of characteristics here, and not necessarily something that I've hashed out very in detail. So I'm not saying this is a coherent theory, but I've noticed that personally in my experience at traditional scientific conferences, there's three aspects of it which are key. The first one is rejection. You have to apply to most conferences. Depending on the conference, the success rate can be below 50%. Even if you're accepted, there are tiers of attention that are built in the conference. So the posters get the least attention. There's some highlights, short oral talks, symposia, then keynote, getting the most attention. Thank you very much. during the conference itself, there is a lot of attention going on that's varying. Some posters are empty, others are full. It's also filled with very intensive social interactions. Human brain mapping, which is the main conference in my field, has a cocktail party, which is attended between 1,000 to 2,000 people routinely, sometimes 3,000. And it's filled with context switching. You've got a very complex agenda where you have to move from one session to another. Each session is itself composed of a fast pace of talks that have been rehearsed for weeks, sometimes for months. So people come extremely prepared and present a very high density of content to you in a very short amount of time. So this is hard for anybody. Most people get overwhelmed at their conference. So if you ever had that feeling, that's normal. It's kind of the way it is. But people who are neurodiverse, and in particular, the one I'm most knowledgeable about are people on the autism spectrum and with attention deficit or hyperactivity disorders. Something that they exhibit very commonly is rejection avoidance. They have a very hard time with this type of dynamics. They can experience social saturation or straight out meltdowns in social situations. And they typically have a very high difficulty to switch between tasks. But some of them still make it to university and to research. And the combination of neurodiverse traits and traditional scientific conference is terrible. By contrast, the key feature of a BrainHack event is actually very compatible with all of this. Emphasis is on collaboration and competition. There's no clear outcome. So there's this whole thing about rejection plays very little role. You'll see that the interaction mostly happen in small groups that are stable over 2 days, which makes it a lot more approachable. And the work is focused on a single project for the duration of the event, making it a lot more friendly for neurodiverse individuals. Now, I actually don't think this is limited to conferences. I've more and more seen that academia is built around principles that push away anybody who's neurodiverse. Anybody really? That's human. But that's a lot harder for people with neurodiverse traits. There's this little schematic that's made by an organization that's called Dragonfly, which seems awesome. I never use their service, but they're organizing tutorials, workshops to help with mental health in the workplace. And so they say that drivers of harassment in academia is an intersection of strong hierarchies and dependencies, where the PI typically directly pays the salary of people working in the laboratory. Competitive performance driven, where the number of papers that you publish can impact your career in a major way. And low team value, individual based. I had a very interesting conversation with a colleague last week about co-first author not being a thing. And actually, in the same committee, which is a recruitment committee, somebody had ranked candidates by number of papers per year. This did not go in. So the intersection of all those things is academia. And on the right, something I haven't talked, but we have very horizontal governance in BrainHack that is in dire need of being formalized, but there is very much power that is being distributed. The emphasis is clearly on team science. We have lots of papers with lots of authors and collaboration, not competition. I dream of a way that this could be actually applied to academia at large and not just into today's event. But in the meantime, I find this an interesting observation. So, I'm weirdly emotional, not sure why, but I'm not going to play this. but I just wanted to explain the title because I'm getting old and I realize like people don't necessarily understand what I'm talking about. To build a home is a song. It's nice. And if you YouTube it, you'll find it. But it just, I mean, the beginning of the song was just about the process of building a house and finding an anchor in the world. And then the house crumbles, goes in dust, and he dies. But that's beside the point. That's not what I want to at all. But I'm not normally like that. Thanks. What I wanted to say with that my part 2 was what's in it for me. And personally, I found a community and sense of belonging in that organization. And I believe it happened because of the characteristics that you described. And I know for a fact I would not be a professor today without it, not because he brought me papers. I succeeded in academia despite an abysmal production rate for other reasons. Maybe because I actually produce papers which have content. Scrap that. It's you know, I have emphasized, let's say, I've tried to emphasize quality over quantity, but I would not have stuck around with just regular conferences format. So to me, it has been literally about building in academia, that is. All right, thanks so much.